Hi students, so today I will conduct an experiment in my house, experiment 1.1 in the textbook. It is about the relationship between the length of a pendulum and the time taken for 10 complete oscillations. Okay, today I will conduct the experiment in my own house, not in the science lab, not in the school, because of the pandemic COVID-19. Okay, so let me play the video that I recorded earlier. Okay, so this is experiment 1.1, chapter 1. So this, you can see this in your textbook, page 36. Okay, I will be assisted by my two assistants. This is Amiratul Kaisara and this is Amirul Kilfi. Thank you for them. Yeah. Okay. So I will use a material and apparatus that I have in my house. Like this one, this is my phone holder. This is a substitution to the retort stand. I don't have a retort stand in my home. Okay. Next, for the pendulum. I also don't have pendulum in my house, but I will use this one. I call this one as fishing bobber or fishing float. Yeah, I love to fishing. Okay, and I attach that one to the thread. This one as a string. Okay, so this thread I already measure at 20 cm until 60 cm. Okay, this is my stopwatch using the handphone. This is the measuring tape. Okay, and then I have a protector for the angle oscillation. So I've used this angle, this protector to measure the angle of the oscillation. So I mark the angle about 40 degrees. So this angle of oscillation will be the constant variable in our experiment today. Okay. So next, we will start with our first reading. This one for 20 cm. The length of the pendulum is 20 cm. Make sure we measure at the center of the pendulum. Okay, so we will start with the first reading, 20 cm. Okay, my assistant will swing the pendulum now. Make sure the angle is there. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we take the reading. For the first reading is 8.97 seconds. Okay, so we record the reading in the table that I've printed earlier. So the first reading is 8.97 seconds. Actually, we need to write only one dot, not two dots. Okay, so okay, no problem. Okay, we to make sure that our measurement is more accurate, so we take the reading 3 times for 20 cm. Okay, so for our second attempt, my assistant will start for second attempt 20 cm. Okay, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we take the reading. We stop our stopwatch. We take the reading and record in the table for reading 2. So now we get 9.13 seconds. Yeah, different from the earlier. Okay, different. So okay, we take the third reading now. This is our third attempt for 20 cm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we stop the stopwatch and then we take the reading. Okay, for our third reading, what is the reading? 9.05 seconds. Okay, now we'll go for the different length, 30 cm. 30 cm, we measure already 30 cm here. We change the length of the string of the pendulum, 30 cm. Okay, so for my next video, I will fast forward because we only repeat the same procedure, only the different now is the length of the pendulum. Okay, first reading Now second reading. Okay, for the third reading. Okay, next we change to 40 cm. Okay, our first reading for 40 cm. Next for second attempt, second reading. Okay, now for the third reading, 40 cm. Okay, now we change the length to 50 cm. Okay, second reading. We take the reading for 10 complete oscillations. So next for 60 cm. This is our first attempt. Next, our second attempt. Okay, and for the third reading, I have a new assistant. This is Amirul Kausa. He want to try. Okay, so let me help him a little bit. Okay, make sure the string are straight and aligned to the mark angle. Okay, so release the pendulum. Are you ready? We count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we stop the stopwatch and we record the reading. Okay, so we finish already the experiment. Okay, so this is the lab report that I've created. So this is the lab report for our previous experiment, experiment 1.1. So problem statement: how does the length of a pendulum influence the period of one oscillation? Okay, hypothesis: the longer the length of a pendulum, the longer the period taken for one oscillation. Aim to investigate the relationship between the length of a pendulum and the period of oscillation. So this is the diagram of the experiment, and this is our pendulum. I use the fishing bobber or fishing float. Okay, so we have three types of variable. First is manipulated variable, length of pendulum. Second, a responding variable, time taken for 10 complete oscillations. And then constant variables, mass of pendulum, angle of oscillation. Okay. Next, we have materials and apparatus. So this material and apparatus, I use phone holder, and then the pendulum I substitute with fishing bobber or fishing float, and then thread, stopwatch, and measuring tape. So this is all materials and apparatus that I use today for our experiment. Okay. From the original that report in the textbook is this one. Let me show you. This is the original. Okay, where the materials and apparatus, the original one from the, if we do the experiment in the science lab, okay, the materials and apparatus are wood, retort stand with clamp, pendulum, string, stopwatch, meter, ruler. However, for a time like this, for COVID-19 in the pandemic, we use what we have in our house. Okay, next procedure. There are four. Number one, a pendulum with a length of 20 cm is used. Number two, the pendulum is pulled to one side and then released to make 10 complete oscillations. Number three, the time taken for 10 complete oscillations is recorded. And number four, the experiment is repeated using different lengths of pendulum. So the different lengths are 30 cm, 40 cm, 50 cm, and 60 cm. Okay. So this is the results. This is the actual result that we have done previously in the experiment. So this is how we calculate the average. We sum all of the three reading and then we divide with 3 to get the average. So this is all the average. Okay. Interpreting data. So this is how I draw the graph. I use a line graph where x-axis is the length of pendulum and the y-axis for time taken for 10 complete oscillations. So what we can say here from the graph, we can see if the length of pendulum longer, then the time taken also longer. Okay, so the conclusion, the hypothesis is accepted, of course, and then the longer the length of the pendulum, the longer the time taken for 10 complete oscillation. So that is our conclusion from our previous experiment. Okay, so thank you.